January 2011. This is going to be video 2 of this series. There it is, January 2011, the New York State Regents exam, given on January 25th. So, this is part 2. We're going to be doing problems 15 through 27 in this segment. Hopefully you've already watched the first video. If you haven't, go look for it. It's around somewhere. Hopefully at some point I will actually work on the show notes and put it in there, but we'll see. Anyway, I'm ready to roll. You ready to roll? Disclaimer, as always, no cheating. Come on, kids. Work on your own. Do your own thing. All right, let's do this. So this is a quadratic. X squared minus 3x minus 10 is greater than 0. Greater than 0 means positive. Now, there are a couple of ways of doing this problem. I will show you both. I could come over here. I could go into my graph mode. And I could do, okay, I'm going to graph x squared minus 3x minus 10. And I want to know when it's greater than 0. Well, it's greater than 0 when it's up in this area, positive. Well, at negative 2 going off to the left, it's positive. At positive 5 going off to the right, it's positive. Down here, it's negative, right? So I want it positive. Positive means up here. So less than negative 2 and greater than 5. There's the easiest way to solve that one. Less than negative 2, greater than 5. Choice 3 is the answer. The other way to solve it is to factor it. X minus 5, x plus 2. And you get your two answers of 5 and negative 2. Put them on the number line. Negative 2 and positive 5. And then test. If you pick 0 and you plug 0 in, you get negative 10. So in this area right here, I get negative. If I plug in negative 10, I get a large negative here, I get a large negative here, so this would be positive, and this would be positive. Plugging in numbers to check, there it is. All right, so let's check this next one. So, if solved by completing a square, an intermediate step would be. So, you know by solving the squared, we want to have the x squared on the left. We want to have the x term on the left, so I'm going to move that over. And then we move, and then I always tell my kids put a box here, because that's why I call it completing a square, is equal to, and then we bring that 2 over to this side, it becomes negative 2. Whenever my mouse decides to work. Negative 2. But we're also going to have to add a box over here as well, because whatever I put in this box, I got to come over here and put in this box. Now, if you remember correctly, you take half of this, and you toss it in a set of parentheses. So half of this is negative 3. Negative 3 squared. That's why it's called completing a square. Half of this gets tossed in here, and then we square it to throw it in there. So that's 9. And we put the 9 over here. So on this side, I'll have 7. And on this side, I have this x minus 3 squared. And there's my answer. Moving on. Hopefully you remember completing the square. 3 marbles are to be drawn. Can I tell you, I actually missed this question. I have not been able to get 100 on any of these Regents exams. And it's not because the math's hard. The math's not hard. It's just paying attention to detail. If you want 100 on this Regents, not only do you have to work hard and practice and know how to do all the problems, you got to know how to check your answers, and you got to know what you're doing, and you got to look back, and you got to really take your time. And I'll show you where I made my mistake, and then you can all laugh at me. Don't laugh too much. So we have 15 red and 10 blue and 5 white for a grand total of 30 marbles. So if I was just to pick a whole bunch of these, and if I was just to pick, looks like we're going to pick 3 marbles at random. If I was just to pick 3 marbles at random, that would be 30 choose 3. So that's all the different ways to get 30 or 3 marbles out of red, out of this 30, without picking, not worried about any color. So it's 30 choose 3. So right now, we can get rid of this one. And you could have gotten rid of this anyway, because there's 3 that all look the same. So that one's gone. So now I want to choose my red marbles. Well, okay, I have 15. And I want to choose 2 reds. And I'm going to multiply that. Yes, you multiply, because I want, this is like an and. I need 1 red marble and 1 white marble. So we've got 5 whites, and we're going to choose one of those. So there's my answer. I come over here, and I somehow very dumbly picked this answer. I didn't even, I looked, the bottom was C3. I didn't even see that there were P's in the top. You see how easy that is to pick the wrong answer? Doing all that great work. This is my answer right here, choice 1. Doing all that great work and then just making a dumb mistake. You don't want to do that. That's dumb. That's just dumb. All right, I've said dumb enough. Oops. All right, kids, here we go. Famous negative exponents. We love to ask negative exponents because for some reason, students still think that negative exponents have something to do with being negative. I have no idea where my mouse is. There it is. Have something to do with negative. They have nothing to do with being negative. Nothing at all. What they do is if you take x to the negative 1, and this is 1 over x. I'm going to say this every time I go through these because you guys forget them for some reason. X to the negative 2 is 1 over x to the positive 2. Oh yeah, that's like a positive 1, but I don't have to put it there. X to the negative 3 is 1 over x to the positive 3. X to the negative pizza is 1 over x to the positive pizza. I don't care what the exponent is. You have a negative exponent, it makes it 1 over. So these answers are gone. You're down to, at least if you know that, you're down to a 50-50 guess. You see how learning some test-taking strategies and some basic knowledge can get you close to the answer? Can't get you to the right answer. Now, the next step is to realize what in the world do fractional exponents mean. So now I'm to the 2/5 power. So I know it's one of these. So you have to remember that x to the 1/2 means the square root of x. Lost my pen again. Let me know when I get it back. There it is. Square root of x. Or x to the 1/3 is equal to the cube root of x. Or x to the 1/4 is equal to the 4th root of x. Notice that the number is on the outside of the square root symbol. Not the inside, but the outside of the square root symbol. So, what I want you to remember is, this is like the ground right here, that fraction. The roots are in the ground. Power up! Roots are in the ground. Power up! Power's on top. Roots are in the bottom. So this is the 5th root of x to the power 2. Choice 4. You can see how all they did was switch to 2 and 5 here. Oh yeah, they're messing with you. Don't let them. Don't let them. Anybody else have as much fun with math as I am? Or some of you just sit there going, I just don't get it, man. This bald-headed freak is teaching me and I don't get it, man. I don't understand. Shut up. Quit whining. Let's get to work. You'll get it eventually. Keep working hard. Pass that Regents. Let me know. Shoot me an email. Make me happy, man. So, when I first did this problem many, many years ago, I do remember this problem many, many years ago, I'm like, wow, this is really easy. And then I realized that I missed the problem because someone showed it to me. I don't know why. I saw it in a book or something similar to this. And I was really mad about it. It says, okay, we're going to start with $180, and each month thereafter, this stock is decreased by 1/3. So, decreased by 1/3 every time it's going down by 1/3. That means it's not decreasing by a set amount. If it decreases by a set amount, first of all, you're in algebra, and you'll be doing that one. So it decreases by a set amount, and this one is decreasing by a set amount, so this one doesn't make any sense either. It's got to be one of these two. So, this one started at 180, and looks like, let's see, every box is what, 20? So this is 120. So that dropped 60. This one started at 180, and it is at 60. I'm like, oh, 60 is 1/3 of 80. Yes, this is the right answer. No, it is not the right answer. This it dropped 120. That's not 1/3, that's 2/3. You want to drop, in this case, we dropped 60 out of the original 180. So this is how much it dropped. It didn't say how much it went down to. This is what it dropped. This is the amount it dropped, and this is 1/3. And here's the right answer. So be careful. That was a tricky question. I know a lot of people miss it on the Regents exam because they, too, picked that other one. We math teachers love to mess with you kids. Don't you just love it? You're like, oh, I get it, I get it, I get it. You jerk! What the? Problem 20. I didn't quite swear. I think I just said heck. You believe me? Okay, so here's what we got. Got no pen. I got JT is 12, JM is 6, and we got a 90-degree angle. And I want to find the cotangent of J. So cotangent of J I'm not great with, but I am great with tangent of J. Tangent of J is opposite over adjacent, because tangent of anything is opposite over adjacent. And here's my angle J. So therefore, if tangent is opposite over adjacent, cotangent is adjacent over opposite. So if this is my angle J, this is my opposite, this is the hypotenuse, and this is my adjacent. So I need something over 6. Ah, shoot. So I'm going to have to do the Pythagorean theorem. So 6 squared plus, let's call it x, plus x squared equals 12 squared. 36 plus x squared equals 144. X squared equals, what is this, 108? 108. Square root. Oh my gosh, there is so much going on in this problem. You got to be kidding me. Maybe I'll show you a different way to do this problem. Nah, this is it. So I got to simplify this. This is the square root of 36 times 3, which is 3 square roots of 3. So I end up with 3 radical 3. So I want to do adjacent over opposite. Oh my gosh, there is so much going on in this problem, kids. So that would be 6 over 3 radical 3. When I simplify it, that becomes 2 over radical 3, which is not, of course, one of my answers. So now I have to rationalize it by multiplying by radical 3 over radical 3, and I get 2 radical 3 over 3. Choice 4. Whoa, that's not the right answer. That's odd. What did I do wrong? Can you find my mistake? Oops, hit the wrong button. Did you all find my mistake? I did. It was stupid. Not gonna lie. So let's take you off to where I made my mistake, if I can find my pen. It's right here. I was going too fast, got a little cocky. How many of you all have taken the square root of 36 before and gotten 3? I just did. I just took the square root of 36 and got 3. I think I'm going to need a new pen. So this actually should not have been a 3. It should be a 6. So I should end up with 6. Oh, this is annoying. 6 square roots of 3 over 6. See, because this should be 6 square roots of 3. These cancel, and I end up with still not a problem. Okay. I just did that wrong again. So hopefully, let me get rid of all this crap, because I got too much garbage in my way. Let me go back to this. Sorry, kids. This is what happens. This is why you do math in the morning, so your brain's not working. So this is 6 square roots of 3. Now remember, this is why I did tangent. I just did tangent. And remember, cotangent is adjacent over opposite. I just did that backwards, and I apologize. So what I should have is 6 over 6 radical 3, which really is 1 over radical 3. And when I rationalize, I multiply by radical 3 over radical 3, and I get radical 3 over 3. Choice 1. Please accept my apologies. I told you I would never get 100 on a Regents exam because I always make dumb mistakes. All right. Remember your rules or your formulas. Sum is equal to negative b over a, and product is equal to c over a. Now, the easiest one to check, I think, is product. So we're going to try to get our product to be 2. So let's see. 4 over 2. This one works. 3 over 1. Nope. 2 over 1. Yep. 4 over 2. So we got rid of one choice on that. Now we're going to have to do the product. Negative b. And we want this to turn out to be equal to negative 3. So this is negative 6 over 2. That looks like it works. That might be our answer. This is 2 over, nope, that's, oh, we already eliminated. This is, now remember, we're going to negate this, so it becomes positive 3 over 1, not our answer. We want negative 3. And this one becomes positive 6 over 2, not our answer. So there's our answer, choice 3. Done. Moving on. Didn't make a mistake. Yay. Oh my gosh. I put this problem on on one of my review assignments, and boy, did it cause all kinds of problems. So you guys realize that you have to multiply. Now, I'm going to always put binomials in parentheses. It makes less. If this was the square root of x plus 2, then you would come over here and you would multiply by the conjugate. And that's what a lot of my kids were doing. They were coming over here and they were multiplying by the square root of x minus 2, the square root of x minus 2. And that would be okay if it was the square root of x plus 2. It is not the square root of x plus 2. It is the square root of x plus 2. So I have to multiply by that exact radical, not the conjugate, because this doesn't have a conjugate. It doesn't have a conjugate because you have to have two things separated by a plus sign. These are two things that are underneath a radical. Not going to work. So you have to multiply by that. So what I get is, and then I'm going to, this is 2x plus 4 times radical x plus 2. And you guys by now should realize when you multiply two radicals that are the same, I don't care if it's radical pizza times radical pizza, you just get pizza. Let me show you. Radical 7 times radical 7. That's really radical 49, which is 7. Radical 4 times, oops, let's do radical 8 times radical 8 is radical 64, which is just 8. So I don't care what you have, radical x times radical x, it's just x, always. So when I multiply radical x plus 2 times radical x plus 2, I just get x plus 2. Now, the good news is they didn't put that on as an answer. That's not one of my answers. That's not over here. But I will tell you, I had a number of kids just immediately, like monkeys, go, oh, look, yeah, right here. No, and then they did, oh, it must be x minus 2. And this shows that one. That's not the right answer. So, no, not the right answer. So what you need to do, this next step you need to do, let me do it in black, is you need to factor this thing. And this thing can be factored right here. And it factors to 2x plus 2. Well, as soon as I see that, and I see an x plus 2 down here, these cancel. And I end up with 2x plus 2. Tricky question, tough one. Loved putting on my spiral. Kids didn't love it so much. Yeah, I don't care. So let's see what we got here. Don't you just hate Windows 8? I hate Windows 8. I can't wait till Windows 10 comes out, which should be by the end of the year. Okay. So what we have here is either a cosecant curve or a secant curve. We have to decide. It is not a cotangent or a tangent. Remember, these cotangent and tangent are ones that do this. So that's not it. So what we have to decide is if we got a tangent or a so really what we got to decide is what was the original curve here. If that's a point, then it probably came back here, and that's a point, and then that's a point, and then that's a point, and then that's a point. And if I graph that, and it starts at the origin, then I'm thinking this is clearly a sine curve because it's starting at the origin and going up. So if that's a sine curve, then the thing riding on top of it would be the cofunction or the reciprocal function, and its reciprocal function is cosecant. All right, moving on, 24. Well, I think the easiest way to handle this problem is, I'm going to show you two different ways. I think the easiest way, I know you guys are just going to avoid me. I'm going to show you the hard way first, and then I'll show you the easy way. And quite honestly, it's not that hard. Just take this thing, log log of 5 of 1/25, set it equal to x. And you remember, it's all about the base. 5 to the x is equal to 1/25. Well, in order to get a fraction, this exponent has to be negative. And in order for it to be 25, it's got to be a 2. So the answer is -2. Now, having said that, there's a much easier way. You just come over here, go to your calculator, and you hit Control log base 5 of Control, losing my pen over and over again, division of 1/25. Hit enter, -2. Boom, there it is. There's your answer, finished. All right, a 4-digit serial number is to be created from the digits 0 through 9. You know, one of the big tricky things about this is 0 through 9 is the fact that that's 10 digits. 10 digits. 0 through 9 is 10 digits. Okay, so I want to create a 4-digit serial number. Now, what you have to do when you're doing problems like this is you have to start with the most restrictive one. And the most restrictive one says this last number has to be a 5. Have no choice. Well, if that's true, that leaves me 9 digits left. Now, of those 9 digits, one is a 0. And they said you cannot start with a 0, so no 0 here. Okay, well that leaves me only 8 digits here. So I'm gonna pick one of the 8 that I have to choose from. So there were 9 digits. I put, because there was, I started out with 10. I put the number 5 here. Now, wait a second though. I just screwed you up. Let me start that over again. I forgot. The 5 must go here. That's why I put this underneath here. The 5 must go here. On top, what you're going to put on top is how many choices you have. How many choices? So, if a 5 goes here, how many choices do I have? I only have 1 choice. Don't put a 5 up on top. You only have 1 choice in this spot. And then that's why I went down to 9. And then when I said, oh wait, you can't put a 0 here. There's 9 numbers left, but I can't put a 0 here. That leaves me 8 choices here. So now of one of those 8's going to go there, so it leaves me, I had 9, now I have 8. So now I have, and you can use anything you want here. So now I have 8 choices for here. I'm going to put 1 in there, that leaves me 7. That means I got 7 to go in here. And you multiply these. And when you multiply 8 times 7 times 1, you get 448. Sorry about making that a little goofed up there at the beginning. We only got 2 problems left. Let's see if I can get through without making any more mistakes. Probably not going to happen. I'll either easy. Okay, so what do we got here? So we've got this point. Let's talk about the center first. The center here is 1, 2, 3. 1, 2, 3, 4, -4. So that means that when I put those in here, this goes in as a -3 squared plus y, and this goes in as a +4. So let's start with that idea. -3 and +4. These two have to go. Can't be. Not going to work. So the next thing I got to do is figure out what the radius is. Well, it said it goes to this point. 0, -1. So what I'm going to do is I'm going to make a triangle out of it. You can't just guess that it's a little more than 4. Because maybe it's exactly 4. Most kids, what they said was, oh, look, that's close enough to 4. They must have made a mistake, so it's got to be choice 1. The answer is choice 2. But let's see why. Well, this is 3, and this is 3. So if I want to find the hypotenuse, I'll do 3 squared plus 3 squared equals x squared, or x squared is equal to 18. And if you remember correctly, on the right side goes the radius squared. And that's why it's choice 2, not choice 1. Which task is not a component of an observational study. So observational studies is you just go out and you just watch things. So the researcher decides who will make up the sample. Well, you still have to make those decisions, right? Don't you have to decide who's going to, what you're going to observe? So yeah, that's good. We're good with that. So let's get rid of that. Well, let's get rid of that. We'll get rid of that. The researcher analyzes data. You always have to analyze data. That would be stupid not to do that. The researcher gathers data from the sample using surveys or taking measurements. The researcher gathers data from the sample using surveys or taking measurements. That might be it. The researcher divides the sample groups into two groups, with one group acting as a control group. Anytime you have a control group, that is not observational. It's that control group that's going to cause you not to be observational. And there's the answer to that question. I'm finished. Guys, it was fun working with you for this second half of part of, what are we in? January 2011. So nice job. Catch you guys on the flip side. Don't cheat. If you get 100, don't forget, email me. I want to know. I'm going to put the wall of fame up on my website, mrkrausemath.com. Don't cheat. If you like what you see, hit the subscribe button. It's down there somewhere. I don't know. It's over there, over there, over there. See you guys.